So chapter 6, inter VLAN routing, or the production of VLANs and why we need them. VLANs are a segment without regard to physical location. You can put your IT users anywhere in the building. So it doesn't matter. In the old way of doing networking, we put all the sales team on one floor, one room, engineers. And so we know that the business model has changed. So now what we want to do is have a lot of different experts in the same areas. So we're going to VLAN, and also VLAN not only just maybe departments, but devices. It makes a logical partition on layer 2. You can create multiple partitions and use multiple VLANs in the same environment. Layer 2 is going to add another encapsulation. So we're going to add another protocol that we need to know and what layer it belongs to. And each VLAN will be its own broadcast domain. So up to this point, we know that the router interface, everything under here is one broadcast domain. So we're going to change that. So, and then you have to pay attention to the membership on the VLANs on your switches and also your trunk ports. So here's your benefits of improved security, reduced cost, better performance, smaller broadcast domains, IT efficiency, management efficiency, and simpler project management. So what we're going to do is allow different IP schemes. So what we want to do, 172.17 is common in every network. So it changes from third octet from 10 to 20 to 30. So these all are different VLANs, and normally they will not communicate until this chapter. So default VLAN is VLAN 1. It should be disabled. Actually, currently in a Cisco switch, if I take one of my lab switches and plug it into the school network, it shuts down that port. So they don't even, the new iOS has enough intelligence to just deactivate VLAN 1. You have a data VLAN, a native VLAN, and a management VLAN. And so your data is going to be for your common devices. Your native is going to be running. Beyond this course, you're going to learn STP, BPDU, which are spanning tree switching loop protocols. It stops switching loops. So just think the native is the things that are untagged, and they're doing switch to switch, maybe router to router conversations. And then your management VLAN would be where you'd want all your SSH, your SNMP, which would be simple network management protocol, and your syslogs. So you wouldn't want maybe some data to go into your management VLAN, and certainly your native to go into your management. So your voice LAN, your voice VLAN, so it's time sensitive, so it's assured bandwidth. Delay is less than 150 milliseconds or microseconds. Transmission priority over other networks. So this is how we set priority on a switch, by doing Q quality of service, QoS, and then the ability to route congested areas. And so your voice VLAN will enable voice IP traffic. And also, if you look at a Cisco phone, you have a port that's acting as a switch on this side. So this is the switch to the PC, and this is the data VLAN, or the voice VLAN, going into the switch. So the switch has a built-in ability to allow the VLAN of 150 to be different than the VLAN 20 that the data traffic goes on. And this was caused by only having one port per cubicle in most offices. So they had to add a phone. Oh, so it's IP phone. So now we have to add, they built a switch into the phone for the PC to connect to it. So VLAN trunking. So from this point forward, we're going to be using VLANs. Everywhere you go, it's a VLAN. And then it's going to be an encapsulation VLAN IEEE 802.1q. So that is VLAN tagging. So what ends up happening is you create membership/chapter. So ports F011 is VLAN 10. So that's switch port mode access, switch port access VLAN 10, and the same thing 20, and then 30 in your respective ports. And then over here, so anytime a switch connects to a switch or a switch to a router, you must make it a trunk port. So from now on, it's either an access port, switch port mode access, or switch port mode trunk. So we're going to control broadcasts because we have different IP schemes. So if you look at, if we broadcast on 172.17.10, it will not go to the 117.17.20. So it limits broadcasting in the environment. So if we, and we will do this in a demonstration, we'll broadcast only on VLAN 10 and see what devices get it. So what happens is layer 2 turns on 802.1q frame tagging. So what you're going to do is when the PC sends information into the switch, it will get a tag of the VLAN. So it's got the MAC address, then it has the VLAN ID, and then whether it's a trunk port. So this new little encapsulation, this new protocol that's added to layer 2, we use Ethernet, but also adds this other 802.1q VLAN tag. Native VLANs, their controlled traffic sent on native VLANs should not be tagged. So if you remember, this is things like routing information or switching information, traffic that the other VLANs do not need to be a part of. So your frames can be received and they're untagged. They remain untagged and placed on native and then forwarded. So you're saving time at that point when you don't encapsulate it with a VLAN tag. If there are no ports associated with the native VLAN, no other trunks links, and the untagged frame is dropped. So when we look at configuring here, switch to layer 3 switch, to layer 2 switch, these all have to be trunked. And then if you go into these VLAN clouds, they'll have to be trunked also. So your voice VLAN tag. So as it states here, we have an access port with a little switch, and then you have your phone on a VLAN. So we'll actually see this. The PC will go into the phone. The phone will put it into the switch. It'll change its, it'll look at its VLAN tag and direct it on based off that VLAN tag. All right, so your normal ranges, so this is going to be test questions. Remember, your normal VLANs go from 1 to 1005 and are stored in VLAN.dat in the flash. And we'll show this with the show VLAN brief. You see that what ports are active and what VLANs they belong to. And we have VLAN 1, and they're all a part of VLAN 1. So your extended range is 1006 to 4096, which is a binary conversion, right? 4096, 2 to the 10th is 1024, 2048, 4096 is 2 to the, what is that, 11? 2 to the 11th. And then your configuration stored in VRAM and your VLAN trunking, we'll learn more about your VLAN trunking ports have to be active on each end of the switch. So here's your new commands. Config terminal, set your VLAN, name it. So look at the prompts. You're in executive privilege, then you're in config T, then you're in config VLAN mode, and then you can end. So what you're doing is you're assigning a VLAN 20 for this PC. It's going to be in VLAN 20. So here we're looking at 2 configs, port 18. You're turning on VLANs with switch port mode access. switch port mode access VLAN 20 assigns membership to the VLAN. And then over here, we can name the VLAN. So we're naming VLAN 20, name student, VLAN 150 voice. And then we went into created our memberships on port 14. And then you can also see that we're doing quality of service because we have a phone with a built-in switch. So it needs to do encapsulation with VLANs and also priority with quality of service on. So QCOS, that's your quality of service. Here we have port 18, no switch port VLAN. So you're taking any membership off. So now it goes back to default VLAN 1. So the question kind of comes in right now. If you delete your VLAN.dat, which is where all your VLANs are saved and all the memberships on your ports, what happens to the switch? You just erased your config, and now what do you think is going to happen? So if you want to do no VLAN, you can take VLANs off individual ports, or you can just go ahead and delete memory location flash : VLAN.dat. And so we'll do that also in our lab or our demonstration. Verifying show VLANs name student specific to VLAN student, which is VLAN 20. Remember, student is just the label. 20 is really what we're going to do the encapsulation with, and we can see here now that show interface is VLAN 20, VLAN 20 is up, line protocol is down. Trunk ports carry all VLAN traffics by default. If you want to prune like as in pruning a tree, you actually go in and you do, so any switch to router needs to be a trunk port. So it's go to the interface, turn on switch port mode trunk, and also assign membership. I'm sorry, turn on not access, but you want to turn on switch port mode trunk, and you're doing native VLAN 99. So common mistake on configs is you only configured S2 with a VLAN native and you didn't do S1. So remember that. And also you're pruning here. You're saying only allow 10, 20, 30, and 99. If you do not do this switch port trunk allowed, all VLANs will be permitted through that trunk port. And most organizations do not put that pruning on. So we can see here, we're going in and turning off trunk port and also taking off the native VLAN, and that defaults back to 1. So you're removing the trunk, and now we're removing the mode access. Another common mistake, do not do switch port mode trunk and switch port mode access on a port. It will disable both. Nothing will work. So what are we doing here? So we're verifying with a show interfaces FA01 switch port. It shows them I'm in trunk mode. I'm encapsulating .1Q, which is just putting a VLAN tag on it, and we have a native VLAN 99, and all trunks are allowed. So very common is the IP addressing when it comes to VLANs. You put the wrong IP on the computer or an end device, and then you put it in the wrong VLAN. So here we have VLAN trunks. You're allowing 10 and 99, and native is VLAN 99. So PC1 cannot communicate with the server because it's supposed to be in VLAN 10, 172, 172, 172, 17. So we have a typo. So once again, a lot of problems occur just by little typos we have. And when you don't work in the environment every day and you know your IPs, that's where you kind of get into that trouble. So show interfaces fast Ethernet 01 switch port. It is inactive. So flow charts, hate them, enjoy them, figure them out, and then you make a video for me. So basically what we're going to do is troubleshoot links and show interfaces FA01 trunk in the trunking mode. So it's a nice show command, but if we're not working every day with VLANs, we probably don't remember them. So common issues are trunking issues associated with mismatched VLAN native. So if you do native on one switch, you have to do them on all switches and the router. And trunk mode mismatches for connectivity loss, and also allowed VLANs on a trunk. So if you prune them, you have to, if you add more VLANs later, you have to go and allow those new VLANs. So we'll do this. So interface is trunk. And we can see that administrative mode is trunk. So we have 01 is trunking on S1. 03 is trunking. So S3 also then must trunk. So why can PC5 cannot connect to student email server? PC5 is in FA018. We look at S3. It's only allowing 99 and 10. So there you have a problem with not your pruning without allowing the VLAN needs to go through. So legacy routing is called legacy routing for a reason, because for every IP scheme, you need a separate interface. So we're going to move into router on a stick and layer 3 switched virtual interfaces. So in the past, every network needed an interface. And so we would have to buy gigabits or fast Ethernets or serials. So it was costly. And then you tied up a port on your switch for every IP scheme. Currently, Barberton has 25 to 30 VLANs. University of Akron, I couldn't imagine how many VLANs they have. So it gets very complicated, and you would not be able to afford a router with 100 gigabit interfaces. So what we're going to do is create a logical interface. So on router on a stick, we create a trunk port on R1, whatever this gigabit interface or fast Ethernet interface is. We're going to create a logical subinterface, give it an IP, turn on the VLAN tagging 8021Q, and then configure the host appropriately. So to configure this, we would go in and do gigabit 0100 IP, no shutdown, go to the switch. Don't need to do anything. You would. You'd have to assign the VLAN, right? So VLAN 10, VLAN 30. So this is how we would configure a legacy. Assign the VLAN on the switch, put access on your port, and then gigabit 00, no shutdown, brings it up. So now we have two physical interfaces to carry traffic into the same switch. So we're going to configure router stick with sub-interfaces of gigabit 00.10 with IP scheme 172.17.10.1. Notice it changes in gigabits 00.20 to 172.17.20. And also gigabit 0030 is 172.17.30. So we have our separate subnetted interfaces. So we're taking one physical interfacing and allows it to carry all traffic. So to configure on your switch, VLAN 10 creates the VLAN. VLAN 30, go into interface, and then also trunk port, so 05. So we're taking whatever end device is in 05, which is a trunk port. So we're taking the 05, a trunk into the router. And then you can see that we would do VLAN on FA011, FA06, VLAN 10, and VLAN 30 respectively. So this is how we configure subinterface. Gigabit 00.10 creates a VLAN. This is a number, it's a tag. This is the encapsulation. On the test, they're going to say, if this is 20 and this is 10, does that affect? It does not. The only thing that matters is the .10. You can put anything you want there. Then the matching IP scheme. Now, every device in VLAN 10 must follow the 172.17.10.0. And then we're going into gigabit 30 to make another subinterface, encapsulate the VLAN tag of 30, and also put your appropriate IP scheme. And then we do no shutdown. Common mistake is you want to put an IP on gigabit 00 because we've done that the whole time. Do not. Just go in and do no shutdown on gigabit 00. Create your subinterfaces. Here's your show command, show VLANs. Shows your VLAN tag. So we're in a router over here, show IP route. We see that we only have directly connected networks. We have no routing protocols running. But we also want to just see that we have our subinterfaces. And remember, the C is the network address of 0. And the L is the exact IP with a 32-bit subnet mask of 255.255.255.255. Add another 255 in there. So configure around our stick. So we'll do this. So we can ping our subinterface. So this is a physical. This is the old. We can do trace route and we can do ping. Okay. Now,